Okay, pan the audience here. Human beings have always relied on tools to assist them in accomplishing tasks, from cooking to construction to transportation. As we advanced as a species, we discovered progressively stronger materials with which to make these tools. So, when materials like metal and glass replaced wood and stone, and advanced technology developed, we had to come up with reliable ways to shape these materials into usable tools. One such solution to this was the lathe. The lathe is a machine that spins a piece of material for cutting to a desired shape. Today, I'll be explaining a lathe's capabilities, different cutting operations, and the differences between manually and computer-driven lathes. So for an overview, let's talk about how a lathe works and what it is, and how it accomplishes what it does. A 2017 article from the Indian Journal of Scientific Research, last accessed February 19, 2021, describes the basic operation of a lathe quite well. It states, "The lathe is a machine tool used principally for shaping articles of metal and sometimes wood and other materials by causing the workpiece to be held and rotated by the lathe while a tool bit is advanced into the work, causing the cutting action." So the lathe is a rather simple machine, and in fact it's actually been around for quite some time. According to a 2006 article by Robert O. Wood, last accessed February 6, 2021, lathes could find their earliest uses grinding glass lenses for telescopes in the 18th century. Since then, they've been used quite often, and in modern society, their utility is quite commonplace in the aerospace, automotive, defense, and common manufacturing industries. So that's what a lathe generally is and how it works and how long they've been around. How does it actually accomplish, or how is it able to accomplish the cutting and shaping of material? Well, especially with metal lathes, the most common type, its extreme rigidity is necessary to basically focus the force into the workpiece and the tool as opposed to the entire machine. This is accomplished through sheer weight. Lathes are very heavy machines. In fact, one of the lathes I work with around every day weighs 25,000 pounds. Not all lathes are the same size, but that's a good middle ground. It should give a good idea of the size of these machines. They're also often secured to the shop floors where they're located. So basically there should be no chance of them, very minimal chance of them moving outside of the physical cutting operation. They also require a tremendous amount of physical power to achieve this cutting. A December 2007 article from Machine Design titled "Lathe Handles Large Through-Bore Turning," last accessed February 19th, 2021, describes a lathe used for larger workpieces. It says that a 55 horsepower drive powers the spindle through 2 gearboxes for 4,000 foot-pounds of torque. So it uses a 55 horsepower motor and it gears it down to achieve a tremendous amount of torque that has the strength to cut metal. Another important aspect of lathes and how they operate and how it achieves this operation is its accuracy. Lathes typically are accurate to the thousandth of an inch, or 0.001 inches is what dimensions are typically measured in. Again, this is achieved through its rigidity, weight, and also the accurately designed components like the travel screws for the axes. And then in CNC machines, they are also measured by computer for further accuracy. So that's a basic overview of a lathe, how it works and how it accomplishes what it does. Let's go over actually what it can do, the cutting operations. The most common being OD turning, or outer diameter turning. That is the most basic and common operation. As I described before, it's basically just a tool advancing into and across a workpiece to achieve a desired contour by removing material on the outside. The inverse of this would be ID, or inner diameter turning, also known as boring. That is achieved by first drilling or in some way cutting a hole into the middle or the inside diameter of a part, and then advancing a separate tool into that recess to shape some extra desired contour. Threading is a more involved process. It's achieved by timing the movement of the cutting tool across the diameter with the rotation of the spindle to cut an even spiral in the diameter of the part. It can be internal or external. The threads are what screws are. Grooving and parting is an operation that's described well by the Indian Journal of Scientific Research article I had previously cited. They explained that in grooving and parting, a square cutting tool is plunged straight into a part's diameter to either cut a finished part from the rest of the material or to create recesses and shoulders. So those are the basic kinds of cutting operations on a lathe. Let's talk about the main differences between manual and CNC machines. A manual lathe is operated manually by an operator and just his hands. It's used, the axes are traversed by a series of hand-cranked wheels, and it is a baseline skill for the industry. Machinists learn on a manual machine first because that is what was first invented as well. They still maintain modern utility in the industry mainly for things like smaller, quicker jobs and repair work. And some safety risks of a lathe, both manual and CNC, mainly have to do with the rotating spindle. Loose articles of clothing, hair, and bodily parts can get caught in a rotating spindle and cause severe injury. Parts can be thrown if not clamped properly or tools not taken care of, and that can cause damage to the machine or the surrounding area. And then the chips or shards of metal that are being removed from the workpiece can be hot and can cause burns if not directed in a safe direction. CNC lathes operate very similarly to manual lathes, with the main difference being that the traversal of axes and just overall operation is done by electric motors as opposed to hand-cranked wheels. This provides for better accuracy and power, also speed, as well as the structure of a CNC lathe is a little bit different. The tool post is located behind the spindle for better visibility of the operation, whereas in a manual machine it's between the operator and the spindle. And CNC lathes they require more training and skill to operate, because there's another layer of complication with the computer and the coding associated with running them. So they are typically more expensive to operate. However, they can give industry a much greater and more accurate volume of parts. So in conclusion, today we have taken a closer look at the lathe, a machine that turns and cuts metal. I explained its overall function, the different ways it can shape workpieces, and finally, I compared the characteristics of manually operated lathes versus ones driven by a computer. Now that you've gained an understanding of this type of machine, I encourage you to pause the next time you pick up a tool or reach for something and think about how it came to be. A lathe just may have been involved. Thank you. There's a repan here.